Word problems with scientific notation. Let's get right into it and practice. So here this word problem is about an airplane that travels fast. It travels at 3 times the speed of sound. And they give us the speed of sound, so how fast is the airplane? So let's first write what we know. The airplane speed is 3 times the speed of sound, and then it does tell us what is the speed of sound. Okay, so that's going to be 3 times 1.225 times 10 to the power 3 kilometers per hour. So when we have scientific notation, you want to multiply same with same. So the number part with the number part, and if there's powers, you can multiply those powers together. So in this case, first we'll do 3 times 1.225, and we get 3.675. And we still have times 10 to the 3, and the units won't change. It's kilometers per hour. So that is our speed of the airplane. So there we go. That's the answer. Let's look at another one. All right. New York has a big number of people living in it. And then also they're talking about the population of the United States, which of course is even bigger. How many times bigger? So what they're really asking us is they're saying, if we have the population of the US, how many times will the population of New York divide into it? That's what they're really asking. So they're saying 3.3 times 10 to the 8 people is the population of the whole US. The population of New York is 5.6 times 10 to the power 6. And again, you want to combine same with same. The number part with the number part, the power part with the power part. So in this case, I'll just round it to 3 decimal places, 0.589 when I divide. And then 10 to the 8 divided by 10 to the 6. Remember, power divided by a power with the same base. You just subtract the powers. So we get an answer 0.589 times 10 to the power 2. Now be careful here. This is not scientific notation. Remember, scientific notation has to have a number. The number part has to be between 1 and less than 10. So the first digit shouldn't be 0. So what we see here is this number part is too small. We need to move the decimal place and make this number part bigger. But if we do that, we have to offset it by making the power smaller. Okay? So we've got, in scientific notation, this would be 5.89 times 10 to the power 1. Now, if you wanted to put that in standard notation, 5.89 times 10 to the power 1, we just move the decimal place to the right 1, 58.9 times, let me not write an X, times bigger. If I were, I would say it's about 59 times bigger. Okay, here's another example. We're talking about one of these moving boxes that has these little styrofoam balls. They call them peanuts in it. And it tells us how many. So we've got quantity in the first case. The quantity of styrofoam peanuts is 4 times 10 to the power 3. That's a lot. And then they tell us the weight of each one peanut. And so each one is small. Obviously, it's not going to weigh a lot. 5 times 10 to the power -4. That's a small number. But we want the weight of all of them put together. Okay? So you can just say the total weight will be their product. Okay? It's the quantity, 4 times 10 to the 3, a lot of these peanuts, and each one weighs 5 times 10 to the -4. So we'll see the total weight. Again, you want to combine like terms. So first we'll rewrite it. We'll do 4 times 5, and then we'll have 10 to the 3 and 10 to the -4. 4 times 5 is just 20. when you have power times a power, you add the powers. 3 plus minus 4. Okay, so we get 20 times 10 to the power minus 1. Now again, this is a problem because in scientific notation, this number right here is too big. We want a number between 1 and less than 10. It's too big. We have to make it smaller. So if we move the decimal place smaller, we have to make the power bigger by 1. So that would be 2.0 times 10. If we add 1 to negative 1, we get 10 to the power 0. So that would be the answer in scientific notation. Now obviously it's a little bit nicer. 10 to the power 0, if you remember, is just 1. So we would just say a total of 2 kilograms. Okay, last example, we've got the distance between Earth and Mars. Let's go ahead and write that. Distance between Earth and Mars, 5.46 times 10 to the 7. And we've got speed that a rocket is going to travel, 4 times 10 to the 4. And how long will it take? So we want the time. Now I'm not sure if everyone remembers, but there's a relationship between distance, speed, and time. The distance traveled equals speed times time. Now we don't know the time. So what we'll do actually is divide the speed on both sides, and we'll have the relationship that the time is going to equal the distance divided by the speed. So let's go ahead and plug that in. We'll say the time is the distance, 5.46 times 10 to the 7, divided by the speed, which is 4 times 10 to the 4. And again, when we're simplifying, we'll do it with like terms. Number part simplifies with number part, power part simplifies with the power part, and we get 1.365 times 10 to the power 7 minus 4, because we are dividing powers, so we subtract. 1.365 times 10 to the 3, and our units are hours. That's a lot of hours. If you wanted to get it, the number in standard notation, you would just move that decimal place 3 places and you would get 1,365 hours. Okay.